Hi, we are continuing our graph series, and in this now I'm going to study this chapter from a book. Like you may have known this book. This is competitive programming book. It is easily available on internet, so you don't have to worry about. Now I have not studied the book completely. I have studied only like 50-60 pages of this book, and I really like this book. So I'm gonna try to study graph from this book. Let's see how it goes. So before studying graph, there is one quote based on graph, which is everyone on average, everyone is on average 6 steps away from any other person on earth. So I guess this idea came from taking the earth complete area and then total people present on it and then connecting them to each other. And this is the same way how graph works. So if you see carefully, this is nothing but a graph. Also, getting more deeper in this is a complete graph. If you don't know complete graph, it is a graph in which one node is connected to every other node in the system. So I guess this came from that only. Now let's not focus on how this code came, but let's focus on the chapter. Many real life problems can be classified as graph problems. Some have efficient solutions, some don't have them yet. In this chapter, in this relatively big chapter, we have lots of figures. We discuss graph problems that commonly appear in programming context, the algorithms to solve the practical implementation of this basic graph traversal, minimum spanning tree, single shortest path, and discuss graph with special properties. So this we are going to study in this chapter. In writing this chapter, we assume the reader are already familiar with graph. I have already taught you some basics of the graph before, so we can study this. If you encounter any unfamiliar term, please read other reference book, browse the internet and search for the particular item. This is the list of important graph terminologies which you should be aware of. Vertices and node are same thing. Weighted, unweighted I taught. Path I taught. Self loop. Directed acyclic graph. Don't get confused. This is directed acyclic graph. Edges undirected, directed, unweighted, weighted cycle. Multiple edges. Tree forest. Okay, so talking about tree is nothing. The only property tree have, which is a general like graph, is a general term which has n nodes, but tree has one special property, which is for n nodes it will have n minus 1 edges. Okay, so this is the property held by tree. Now sparse graph, if we don't know about sparse graph, let's search. Okay, whatever we don't know, we are gonna search in this series. So what is sparse graph? So sparse graph definition is simple: a graph in which number of edges is much less than the possible number of edges. Okay, so if we go on to diagram dense versus sparse graph. So dense graph is graph in which there are large number of edges. Typically the number of edges is close to the maximum number of edges. A sparse graph in which there is a small number of edges in case the number of edges considerably smaller than the or lesser than the maximum number of edges. Okay, so this is a dense graph and this is a sparse graph. Okay, so I guess we should not have any confusion in this. If we go fix the definition, we can here actually. So this is a sparse completed isolated graph. Again, we don't know. We are gonna search. Let is a vertex in if it has only a self edge. Okay. Okay. Isolated vertex in a graph. This is not isolated graph. This is isolated vertex in a graph. Is a vertex that has no edges connected to it. Okay. Meaning its degree is so isolated is nothing but this is isolated. Like let's consider its naming is one. So this is one node and no degree is connected, no edge is connected to it, so this is isolated. Okay, multigraph, what is a multigraph? Okay, so let's search. Multigraph is a type of graph in which multiple edges can connect the same pair of vertices. So what does it mean? If I talk about multigraph, so you can say a multigraph is nothing but type of graph in which multiple edges can connect the same pair. Okay, so let me tell you what is multigraph. So consider these two are two vertices. So one edge goes from here to here. Another edge can go from here to here. This is the same as this, but as we have multiple edges, so this become a multigraph. Okay. Now what is a Unarian? Let's search. Unarian graph is a connected graph in which every vertex has an even degree. This means that each vertex in a graph connected to an even number of edges. So now this here comes the definitions. If we try to stick it here, So now we know Unarian graph, a graph that contains Unarian circuit. What is Unarian circuit? A closed train that uses each edge exactly once and return to the starting vertex. Unarian path, an open train that uses each is exactly one and starts and end at different vertices. Okay, so Unarian graph is nothing but a connected graph in which every vertex has an event degree. Let me explain you. So consider these three. If we connect these, so this has two edges, this has two edges, this has two edges. So this is a Unarian graph. Okay, but not a Unarian. Okay, so path is like this, but as we start and end from the same place, this will not be a Unarian path. Okay, Unarian graph completed. Unarian circuit is nothing but a closed train. Like how we move, this is just a Unarian circuit. Okay, that uses each edge exactly and returns to the starting vertex. It returns where it started. Okay, Unarian path complete. Semi-Unarian graph. Graph that contains Unarian path but not an Unarian circuit. Okay, so what is a meaning? It has exactly two vertices of odd degree. What does it mean? It means that it has an Unarian path but not a Unarian circuit. So by this what I mean is, consider this, this, this. So these two have two edges, but we see exactly two nodes don't have even edges. This has only one edge, this also has only one edge. Okay, so here also semi-Unarian graph. This is semi-Unarian graph. Semi-Unarian graph. Okay, connected graph in which there is a path written. So connected graph, like one is connected to three. How? By this path. If we can go from any vertex to any other vertex, whether the path is like this because this has nodes here, but as we can go from 1 to 2, so this is a connected graph. Okay, event degree, no need to tell. Hamiltonian graph, so this is a good in which there contains a Hamiltonian cycle, which is a closed that includes all vertices exactly once, but this is not directly related to Unarian graph. So I have always been confused between Hamiltonian and Unarian. Okay, let's see if my confusion gets clear here. Traverse 7 graph, in a graph that can be drawn without lifting a pen from the paper and without retracing any edge, which includes both Unarian and semi-Unarian graph. Okay, so I saw that we can create this path like this without lifting the pen, and similarly we can create this without lifting a pen. So traversable graph is that if we only go to every vertex once without retracing any edge. So now what is Unarian orientation? Hamiltonian I leave for now. Okay, Unarian orientation, an assignment of a direction to each edge of An undirected graph such as the in degree of the vertex, each vertex is equal to its out degree. So of edge of an undirected. Okay, so consider we have been given this graph. Now we have to choose one direction such that in degree becomes equal to out degree. So if I just do like this, we can see that in degree is equal to out degree. Okay, so I mean in degree is equal to out degree. Similarly here, this is for each vertex. So this is Eulerian orientation. Okay, multigraphs I told. So this is on the only thing, like I should write here multigraphs also. One, two, multigraphs. Okay. Now we know about Eulerian. Eulerian is nothing but each vertex once and even number of edges. Semi-Unarian only two nodes have odd number of edges. Okay. I guess the doubt must be clear. Set E is nothing but 1, 2, 3. So these three nodes are in one set. Told you about dense graph. Reachable is just like traceable, or I should say connected graph. Simple graph. Simple graph is nothing. Bipartite. Okay, so now bipartite. Okay, wait, let me tell you about simple graphs also. So why or what is exactly a simple graph? So this is nothing but an undirected graph that does not contain any loop or multiple edges. Like no multiple edges, only single edges. Each edge connects. There is at most one edge between any pair of vertices. So it is nothing but any graph you draw. Like this is also a simple graph, because if I say then this is one path. Okay, only one path between two vertices. Now what is a bipartite graph? I may have told you bipartite, but let's see if we are going to study completely. We study without any cheating. Bipartite graph. So the definition of bipartite, we can go here, but this would make it complicated. Instead, I want a simple definition. So can we get some simple definition of bipartite graph? Okay, so Then this is the definition of complete graph. We have to stick it, I guess I should here. So this was actually a good PDF to learn about bipartite graph. These are the properties of bipartite graph. What happened here? I don't know what happened. This is bad. I don't know why I cannot put the image in the PDF right now, but leave it. Let's study. A complete graph is a graph with n vertices and edge between any two. I told you. We use the symbol Kn for complete graph with vertices. And a bipartite graph is a special kind of graph in which the following properties. It consists of two sets of vertices. The vertices are joined can join only with the vertices of set Y, can not with set X. The vertices within the same set do not join. And some more properties are like bipartite graph contain no odd cycles. I want to paste it. I don't know what I'm unable to. I don't know what happened. So before that, let me stick it somewhere else. Cannot paste the picture here. So I guess I will have to stick that picture. Where I'm gonna stick that picture. Okay, so it got finally stick here. Now can I remove it here? Yeah, so finally got it. So these are the three properties of the bipartite graph. It has no odd cycle. Every subgraph of a bipartite graph is itself bipartite. In any bipartite graph with bipartisan x and y, sum of the degrees of vertices of set x is equal to sum of degrees of vertices in set y, obviously, because x is simply x is connected to y, so y is also connected to s. This only means that, okay. So now let's move on to the next thing. We studied about bipartite graph GVA. Okay, so wait, let me select highlight. So this is nothing but vertices graph G with vertices V and number of edges E. Okay. In degree and out degree nothing but I told you if it's coming then in degree, if it's going then out degree. Okay. Big deal. Now connected I told you if we can go from one node to another subgraph, a part of graph, complete graph, every edge connected to any other directly. Okay. Okay, so I told you about the ways in which I can represent the graph like adjacency matrix, adjacency list, edge list. I have not talked about edge list and implicit, but I told you that we mostly use about adjacency list. Okay. So this is about ACM ICPC contest. How graph problem comes. There is at least one or possibly more problems in an ICPC. Okay. However, since large, if you want to do well in ACM ICPC, you have no other choice but to study and master on these materials. Okay. So just do this for the for IOI, you know, International Olympics of Informatics. This is okay. So now we have graph traversal methods like DFS, PFS. So we will study this tomorrow.